Measuring and recording time represents one of the oldest scientific activities undertaken by early civilizations. The story begins with ancient people positioning huge stones to greet the rising sun at solstice. This story flows through thousands of years of discovery and invention, leaving us with the precision electronic timekeepers we use today. This DVD tells part of that story, demonstrating how the rotating Earth is the heartbeat that defines time. Turning in the sun, we experience sunrises, sunsets, and a revolving parade of nighttime stars. The motion of our planet is the foundation of every clock on Earth. The passage of time is revealed in the natural cycles around us. The tides, the phases of the moon, sunrise and sunset come and go with a natural rhythm. Incredibly, the human mind recognized these cycles and created instruments to measure and record time. The earliest people marked the important sunrise of solstice with standing stones. As knowledge spread, temples appeared on the landscape. Stonehenge, created over 3,000 years ago, is in fact an ancient timekeeper. Its huge pillars of stone carefully placed to record and predict the rising and setting of the sun, moon, and stars. The flowing sand of an hourglass or the moving shadow on a sundial represent knowledge descended from the ancient timekeepers of the earliest people. Late in the 16th century, a young Italian philosopher discovered pendulums. Galileo's discovery produced the first accurate ticking clocks and started a revolution in the creation of scientific knowledge. Driven by gravity, pendulum clocks are still in use today. In November of 1761, John Harrison, a determined English inventor, using the elastic force of a spring, presented the world with a clock that ticked with unprecedented precision. Harrison's invention influenced history. On July 13, 1772, Captain James Cook sailed from England carrying one of Harrison's clocks. Precise knowledge of time is essential for navigating the planet. Ticking steadily throughout the voyage, Harrison's reliable timekeeper guided Cook and his ship on a voyage of discovery to the South Pacific. Cook's voyage and Harrison's invention marked the beginning of a new era of world exploration. Modern digital watches replace swinging pendulums and oscillating springs with vibrating atoms, producing microsecond accuracy. All clocks display time as dictated by our rotating planet. Our planet travels through space orbiting the Sun. Each trip around our Sun takes 1 year. As our planet orbits, it spins on its axis, completing a rotation every 24 hours. Add a pointer and a dial to our planet, and you have created a huge clock. As we will see, to design a clock, you must understand the Earth's motion. Our next stop is the North Pole, a great place to create a device for measuring time, a sundial. During the summer, the sun shines 24 hours a day at the North Pole and presents a unique situation for creating a sundial. Here at the North Pole, while it's cold enough to be at the North Pole here this morning, it's relatively easy to create a sundial. All you have to do is shove a stick in the ground, the Greeks named this shadow casting stick the gnomon, an ancient word meaning the interpreter. The gnomon translates the sun's position into time. Lines in the snow will provide us with a rough scale. This is not an accurate scale I am creating, but it will serve to show how the shadow moves around the gnomon as the day progresses. As the Earth rotates, the shadow moves smoothly around the gnomon, arriving at its starting point 24 hours later. The face of an accurate polar sundial has 24 radiating lines, spaced 15 degrees apart. This is because the Earth rotates through 360 degrees in 24 hours. 360 divided by 24 is 15. The Earth rotates 15 degrees each hour. 30 degrees represents 2 hours, 45 degrees 3 hours, and so on. A completed dial has 24 equally spaced lines. Add a post to this dial, place it at the North Pole, and we have an excellent sundial. The shadow from the gnomon displaying time in 1 hour intervals.